Okay, so you're going to find out what this I is, and it is one of those things that's a big deal, kind of like pi. You get that pi is just a letter that they have assigned a special thing, that it's always going to be 3.14? I is assigned a special thing. It's a job in math. You will never see I used as a variable. You'll see X's and Y's and A's and B's and Q's and P's, but you'll never see an I as a variable. Just like you never use pi as a variable, do you? Pi is just 3.14, right? Well, I is defined like that, and I is special because it has to do with this problem. This is where it came from. See, people were theorizing, well, what does square root of 25 mean? Square root of 25 means, okay, well, it means something times something that could make 25. And I get, we had this discussion before about, is there two answers to this? And I think some of you still think that -5 is the square root of 25, and it's not. If you graph this on your calculator, it'll tell you only one line. It'll give the line y equals 5 as the answer, because it's not 5 and -5, it's just one thing, okay? But then they were thinking, well, what could happen then if we try to do the square root of -25? Well, judging by the context of the conversation, do anybody want to take a shot at what they think the answer is? And you'll probably get it right. It's not rocket science here. Yes? Oh, you're right. Not in the real world, but with imaginary numbers you can. Yes, mathematicians made up something called imaginary numbers. And imaginary, now just here's the really weird part. They made up an imaginary thing, and they even called it I for imaginary. And these imaginary numbers can actually be used to solve real problems. In fact, without imaginary numbers, electrical engineers, who are very brainy engineers, my daughter's a mechanical engineer, and she'll tell you that the electrical engineers are usually the brainier, like they're the even geekier than a normal engineer. They're the ones who dig into the really deep, complicated electrical flow issues of, you got electricity flowing through your Tesla car, right? And you got to know how much electricity is going to fall out along the way from resistance and etc. Anyway, these guys need imaginary numbers to solve real world questions about electricity. Like, they couldn't do it without imaginary numbers. So something imaginary and made up has come in handy to solve things that they needed to know in the real world. Okay, so I just don't want you to think imaginary equals like, leprechauns and other things that are, kind of useless, just made up stuff. This actually can be used in the real world. All right, so here's how you do it. You say square root of 25. Would you agree that could be square root of 25 times the square root of -1? Just, it's two things multiplied, right? I mean, just like you break up square root of 8 into square root of 4 times the square root of 2, at least do you know that? You can do that. And therefore, this one would be like 2 root 2. You guys get this by now, right? We've been practicing that on the top 20. If you don't get that yet, you got to get it down now, because it's going to be on your next major test. Well, in this, root 25 can be broken into root 25 times, you can make anything 2 square roots if you want to break it up into its factors. And why did I pick that particular one? Because mathematicians have defined the square root of -1, we will just always call, what do you think? I. And then I know this, the square root of 25 is 5. Notice I'm not saying plus and minus 5, it's just 5. And what's this again? I just said it. So the answer is 5i. If that blows your mind just too much, then just go back to, this is like the answer for this is 5, and that makes it imaginary, so it's 5i. Yes? Oh, why? Okay, good question. Why do I make my eyes like that? It's honestly, it's just a little style thing, and it makes it look a little less like a absolute value sign or a 1, because sometimes an I, just an I, did you get if I say 5i without the dot, would look a lot like a 51. Know what I mean? So yeah, it's just because of that. Same thing with t's. If that could be a t, then you get it's also kind of like a plus. So what I've found we usually as mathematicians will do is put a little curve in the bottom of it. That way if it's supposed to be a t, I write that instead of a straight up and down one. Otherwise it would look like a plus. And this I would look like a 1. That's all. That's all. The only reason I put a little curve on it. You can do it if you want. I don't care. It doesn't matter to me. Just make sure it doesn't look like a 1, and I don't think your answer is 51. Of course, I'll know on the test I'm looking for an I, so it won't be hard. Yes?
So, you're always like to use like a new letter for a variable?
Yes, and you were lied to. You can't use an I. And there's a few others. This is high-level stuff. Like usually we pick the Greek letters to be the ones that you kind of use for special things. Like there's another one called phi that's defined. There's another one, but there's another letter you can't use, E. Did you know that? I don't know if you've ever noticed that on all of your math assignments in the past, you've never had a variable that's E as an elephant. Or if you did, the teacher made it up and shouldn't have. Because the E is defined as a number. It's 2.718, not repeating, but it goes on forever and never repeats. It's kind of like pi. It's an irrational number that's defined. So E is another one that's off limits. So E and I and pi, they're all like set values. They're not variables. Yes? Good question. It would take me all hour to explain. It's used, it's a cool number found in natural patterns. Like, for instance, it's used in compounding. Like, let's say I have 23 deer and then I use a compounding rate to say that it's going to grow by, like, say, a certain percentage. E is used when you compound a number. Like I said, it would take me a long time to explain. There's one more place you see it on your calculator. LN. Have you ever seen that button before on your calculator? It stands for log natural, and the natural log uses E as its base. This is getting really deep, but the point is there are some letters that are special, and I is special. You will never use I as a variable because I is defined. What did I just say it was 2 seconds ago? Square root of -1. Okay, so now, how does that like come into play? Here is a typical question, and it's as easy as you think. What's the answer? 12. What's the answer now? 12i. Why? Because I can break this into square root of -1 times square root of 144, and I know that one's 12, and I know that one's I, so it's 12i. Make sense? All right, try this one. -27 square root of it. Simplify it down as far as you can. I will pause for a second while you try that. Did you say square root of 9, square root of 3, and the square root of -1? It doesn't matter what order, but do you get those would be the logical ones to use? Because root 9 is actually 3. Root 3 is just root 3. Don't try to simplify that. You don't know what that is. And last is, what's that? I. Now, in order that we usually like it, we usually like to put the I in front of the root. So 3i root 3 would be my preferred way of writing that. And that shows that we had an imaginary answer in it because it's got the I in it. All right, here's other things you might want to know. I acts just like a variable. If I say 3 times that, it is as simple as you would think. 3 times 2 makes 6, plus 3 times I makes 3i. It's just as simple as you would think. It just moves around like a variable. Okay, so it acts just like an X or a Y or a Q. It's just you can't stick anything else in it because I has to be the square root of -1. All right, so knowing that, would you please figure out what 3 plus I times 2 minus I comes out to be, and be very careful. Just start with plus. I'm afraid you won't be able to handle too many negatives in there at once. Would you please multiply that all the way out? Hint, it's got 4 parts, just like always. First, outside, inside, last is the way I do it. You can do it a different way, it doesn't matter. But put it all together into one final answer. I'll pause, we'll give that a try. All right, so you should have said 3 times 2 is 6, and then the outside ones I'm going to say, and then the inside ones are plus 3i plus 2i, and then the lasts are going to be I times I is I squared. Then I put the 2i and the 3i together, 6 plus 5i plus I squared. And that is right so far. How many of you are right so far? Okay, good. Now, here's the thing that you probably didn't know. That I squared is going to be I times I. And that means, here, I'm going to break it down for you. I squared is really I times I. I think we'd all agree with that, right? And next, isn't I really the square root of -1 times the square root of -1? And then do you get that at that moment, a special property kicks in, and it is that whenever you have two square roots that are exactly equal to each other, like, I'll give you an example, root 5 and root 5, do you get that's actually root 25? And therefore it's 5. So this equals 5. Hint, root 7.1 times root 7.1. You know the answer. 7.1. So what do you think I squared is?
Well, I'm not sure.
Just wait, let me finish it because I need somebody to see this. It's not 1. Yes? It's -1. What I said a second ago is that when you have two things that are multiplied like this, that the answer will be whatever's underneath the root. Moral of the story, after all of this, is that I squared is -1. Whoa! In fact, that's something that you can use on your next time you take the ACT test. At some point, you probably want to go to college, and that means you're probably going to have to take the ACT or the SAT, and either one of them expect you to know this one major fact, that I is special, it's the square root of -1, and that I squared, therefore, is -1. So let me go back to that last slide. You guys were all right if you got to here, but now you can be even more right by saying, what's that equal to? -1 goes with the 6, makes a total of 5. And no, not an I. This is just -1. Oh, I see what you're saying. You were saying this part of the answer, yes. So this part is -1 goes with this 6 and makes 5, and it's 5 plus 5i. And I want you to also know that we always put the real part first and the imaginary part second. So the I will always be last. Unless there's a square root involved. If, like I said before, if this had a square root of 3 in it, you can put the I right in front of that square root. But this is the real part. This is the imaginary part. That's what makes it complex. So here's one of the biggest confusions. People will go, one kid will say, we learned about complex numbers today. And another kid will say, we learned about imaginary numbers today. And they're both kind of right. Do you get an imaginary number can be thought of as anything with an I in it? You with me on that so far? And that a complex number has a real part and an imaginary part. It's complex. It's got a real part, it's got an imaginary part. All right, so let me ask you this. 5. Is that imaginary? Is it a complex number? No. How about now? Is it an imaginary number? Yes. Is it a complex number? Yes, and here's why. This is kind of a technicality. It's a complex number because it has a real part. It's just that the real part is 0. That's a complicated. That's like a technicality, but it's true. And even a lot of math teachers don't get this, so it's okay if you don't get it. But 5i is a complex number. It's not just an imaginary number, it's actually complex. It's just that its real portion is 0. So I've seen this in a joke before, that, you know, like there's some I sitting over in the corner pouting, and then it's hard to do that in a comic, but anyway, And then they say, oh, she prefers to be called complex, not imaginary. And anyway, anything with I in it is a complex number. It's just that sometimes the real part's 0. Okay, I know that got kind of deep. So we only have one more thing, and then believe it or not, I will have taught you everything for the next 2 days. Today's is really simple, and tomorrow's was going to be kind of a medium, easy-ish. I put them together. Why? Because that gives me time tomorrow to take you outside on one of the most beautiful days left in Minnesota, and I want to do the drone day. So I'm going to take you outside and fly the drone with you. You can do a little bit of math related to that drone that'll be hovering in the air, and it'll be kind of cool. And you don't get to do that often here at school. So thank you to the Minnetonka Foundation for providing that drone. All right, so drone days tomorrow. If I were you and you're one of those freeze box that's like got no fat on you, you might want to bring a jacket or a sweatshirt or something like that, because we're going to go outside. I won't be cold at all, but some of you guys will be. So anyway, feel free to bring a sweatshirt or a jacket tomorrow to class. I'm going to start here, and we're going to head outside. Okay? All right. The last thing I got to teach you is this. If I had I, it would be equal to I. Ooh, that's hard. What if I had I squared? I just did that a second ago. It's -1. What about I to the third? Hint, it's really just I squared times I, isn't it? Do you get if I put a 1 here, you can see that that's actually equal to that? And if it is equal, then I know that this part's equal to what? What's I squared again? -1 I. So that's -1 I. I can drop the 1 and just say negative I. I is weird, no doubt about it, because you don't normally do this and put something to a power and have it keep changing its value back and forth between i's and 1's and -1's and +1's. And all right, I'm going to do another one. What do you think I'm doing next? I to the 4th. And do I expect you to memorize all these? No, but I expect you to be able to figure out any of them. Like, if I said I to the 17th, you can figure out what it is. Watch. I to the 4th, it's always going to be a bunch of I squareds. And maybe there'll be a leftover I, and sometimes there won't be. All right, how many I squareds do I have here? Is there a leftover I, or is there nothing else? There's nothing else. So then, what's that equal to? It's -1 times -1, which is 1. Look at that. They came out to 4 different things. But now it's going to start to cycle. I to the 5th. It's a bunch of I squareds first. I squared times I squared. And is there a leftover I? Yeah. And therefore, think about it. What's it equal to? -1 times -1 times I makes what? Isn't there an I left? -1 times -1 times I. I. Now, the first 4 is the pattern, and it just keeps cycling over and over from there. It's like a repeating decimal. You know, like 0.35 and then 35, 35, 35, and it keeps repeating. This one's going to keep repeating. So if I do I to the 6th, I don't want you to try to memorize these with some dumb rule like, well, if it's ever even, then you gotta, don't do that. Because there's too many possible combinations. It's either negative or positive, and it's either I or it's 1, and there's too many possible combos. So every time, I just want you to go like this. I squared, I squared, I squared, I know you could make up a rule for this, but the rule would be much more complicated than this. Make it into a bunch of I squareds. Okay, so what is I squared times I squared times I squared? Well, it's -1 times -1 times -1. And if you could just remember that I squared is -1, that's like the main thing from today. So, what is -1 times -1 times -1? -1. Was there a leftover I at the end? Nope, so it's just -1. All right, see if you really got that. What would I to the 8th be? Hint, bunch of I squareds. Think it through. The answer is either I or 1, and it's either positive or negative. That's what you have to figure out. Bunch of I squareds. Write down what you think it is and compare with the kid next to you. Okay, I'm seeing a lot of people agreeing with the kid next to them. It was I squared, I squared, I squared, and I squared. And they're all -1, and that's negative times negative times negative times negative, and that makes +1. Raise your hand if you had +1. Okay, good. All right, cool. So here's, like ahead of time, here is a whole example of all the things we'd expect you to know. If I said this, 4 plus 3I squared, could you simplify that down to just a nice simple number answer? Good. Because you're basing it on I squared is equal to what? -1. All right. So then that's 4 plus 3 times -1, and that would make 4 plus -3, and then that would make 1. Also, could you do I to the 17th power? If you had the time to do it, could you do it? Put it into a whole bunch of I squareds, and would there be a leftover I or not? There would, and therefore the answer is I. And then it's just whether it's positive or negative. And I don't say it. I'll let people figure it out for themselves. All right. Next, what if I said this? 2 plus I times 3 minus I. Do you get, you could multiply it all out and you'd have an I squared in the answer? And then do you get, you just have to change the I squared to a -1. That's all there is to it. And then the last thing, the most important, difficult thing is this. You know, on the square root of, when you do the quadratic formula, sometimes you get answers like this, and you saw these on the top 20, except they never had a negative under the square root. We practiced this already on that top 20, and so therefore, I'm hoping this isn't that bad. The only thing is, do you get this will have an I in the answer? All right. And also, please don't think you can cancel like that, that you can't cancel like that, because this is part of an add problem. If this 2 here is part of an add problem, I cannot cancel like that. So, would you please try that one? And then we will have covered pretty much everything. And the test is on Monday. Got a, you know, it's a full week from today. Got a lot of time to process this. Granted, several days of that is a long weekend, but. And if you were doing the top 20 and you know never got this one before, now's your chance to finally get it down. Guess what makes it imaginary number? Because I got a negative underneath the square root. That's not normally possible. So I hope you knew I'm going to make this into root 4 and root 2, but then I wouldn't be dealing with the negative. So I got to say root -1. And that makes it an I. This one's 2. This one's square root of 2, and this one's an I. And then I clean it up, 2I root 2. Raise your hand if you had 2I root 2 right there. Awesome. Now I'm going to rewrite it. 2 plus and minus 2I root 2 over 2. There's 2's everywhere. I don't want you to just go like that because you're going to think somehow that if there's 2 on the top and 1 on the bottom, you cancel them. That there's no such thing. But I can factor the 2 out. Go ahead and factor this top part. And then you can cancel. Yes?
Why did you put the I?
Because we don't like to have the I at the very end because it looks like it's underneath the square root if you put it there. It's just the way it looks. So as long as you're really careful, if you let your square root stray a little too far and all of a sudden your eye's underneath that root, I'm marking it wrong. So the safest thing is to put it in front of the root. But Technically, I would have to mark it right as long as it wasn't under the root. But I just recommend you put your I up in front here. All right, now this factoring out part, some people still don't get it. It kind of boils down to like this. If I had 2 plus 2 times 3a, do you get I could factor a 2 out of that? And I go 2, 1 plus 3a. That's essentially what I'm doing. It's just factoring out a 2. There's one here and there's one here. I can factor it out. There's one here and there's one here, so I can factor it out. I take the 2 out, and what I have left, though, needs a 1 here. A lot of people think it just disappears, but if there was no 1 there, then when I multiplied it back out, this times this wouldn't exist, and I wouldn't get my 2 back. So there has to be a 1 in front. Most people get that, but there's always like 3 kids that think that somehow when you take the 2 out, it just disappears. There isn't a 1 here, but there is. Okay, and then there's 2 on the bottom, and then those 2's cancel, and your final answer is 1 plus and minus I root 2. Raise your hand if you had that one right. Sweet, you now know everything. I wish we could just test tomorrow and be done with it. But we're going to give you a little bit more practice, but that's essentially it. You get a chance. I know some of you get this, and some of you are like, I'm not sure I got all of that. Well, you got some time. Remember, tomorrow, you're going to bring a light jacket / sweatshirt or whatever you normally wear to school when it's cold outside. Okay, and because we're going to do the drone thing. Then your homework for tonight has 2 parts, and it's not due tomorrow, because tomorrow we're going to spend a lot of time outside. Okay. Remember, we start here, though. Come to my classroom first. And the homework for tomorrow has 2 parts, one of which is this worksheet right here. And I want to start it with you. It's actually under tomorrow's date. Like I said, I'm doing today's homework and tomorrow's homework. Today's homework is a homework quiz, and I can't fix the due date on that, so technically that's due tomorrow. So if I were you, I'd start with the homework quiz, which is under today's date. Then tomorrow's looks like this. Would you please find this one? I'm going to pause for a moment while everybody finds it. If you have already found it, start doing it. It's as simple as you would think. You just multiply this puppy out, see what you get. Hint, there'll be an I squared in it, and therefore you should convert that to -1. I'm going to pause while I make sure everybody's found this worksheet. Okay, I think everybody's got it now. 2i times 3 makes 6i. 2i times 7i makes 14, positive 14, what? I squared. Then you go, ooh, I know what that is. That's -1. Notice that's 14 times -1, which makes it -14. And then I just write the final answer. The real part goes first. -14 is real because there's no I on it anymore. Plus 6i. Now, if you wrote that backwards, just remember the real part's supposed to go first. Let's do another one. I'm going to jump over to number 6 because my recording box is over the other one. This one times this one makes positive 36. And then the outside makes positive 6i. Then the inside makes 7 times 12. 84? Do I have that right? Okay, 84, and then it's 2 negatives, so it's positive 84i. And then the last is this times this, which makes positive 14i squared. Now you simplify that down, it'll be one of these answers over here. Did you notice that -14 plus 6i, boom, it's right there. There's an answer bank. It's kind of nice. You can know whether you're doing it right based on your answer bank. And last but not least, at the bottom of the sheet, IN goes with problem 1 then, right? And on number 1, the answer was found under IN. So if you go to the bottom of the sheet and you look at the number 1, it goes with IN. And it'll spell out a saying at the end. Okay, I get that in the homework quiz. I think the homework quiz is going to be easy. Remember, if you want to type in square root, you say SQRT. That's how you tell Schoology that you're trying to say square root. So if you wanted to say, you think the answer is 6i, or how about square root of 6i? You could say, I like to put the I first. And I think it'll accept it either way, but you type into Schoology I SQRT 6. Get what I'm saying? For the Schoology quiz part of this thing. Okay. That's all I got for you for today.